Download this code from codegive.com, link in the description below. Are your TypeScript unions really working? Diving deep into advanced union types. TypeScript's union types are a powerful tool for expressing the possibility of a variable holding one of several different types. They're crucial for creating flexible and robust code, especially when dealing with external APIs, data transformations, and complex state management. However, mastering union types requires understanding their nuances and potential pitfalls. This tutorial delves deep into advanced techniques and potential broken scenarios with TypeScript unions, offering practical code examples to solidify your understanding. 1. What are TypeScript unions? A quick recap. At its core, a union type in TypeScript declares that a variable or parameter can hold a value of one of several specified types. You use the pipe operator to separate these types. This is a fundamental concept, but the real power emerges when combining unions with other TypeScript features. 2. Discriminated unions, tagged unions, the foundation of robust union handling. Discriminated unions, often called tagged unions, are a specific pattern that dramatically improves type safety and predictability when working with unions. They rely on having a common, literal type property, the discriminate or tag, within each member of the union. This allows TypeScript to easily narrow down the specific type within the union based on the value of this discriminate. Why are discriminated unions so important? Type safety. TypeScript can intelligently narrow the union type within if or switch statements based on the discriminate, preventing errors when accessing properties that only exist on certain members of the union. This is called type narrowing. Exhaustiveness checking. TypeScript can help you ensure that you've handled all possible cases of your union. You can configure the strict null checks compiler option and use return types, as shown in the next section, to get warnings if you don't handle all cases. Readability. They make your code much easier to understand because the discriminate clearly indicates which type the variable is currently holding. 3. Exhaustive checks and the never type, ensuring completeness. TypeScript provides mechanisms to guarantee that you've handled all possible cases in your union. This is especially important when refactoring or extending the union later on. The never type plays a crucial role here. How it works. 1. The never type. Never represents a type that will never occur. A function returning never returns at all, example, it always throws an error or enters an infinite loop. 2. The default case. In the switch statement, the default case attempts to assign the shape to a variable of type never. 3. Exhaustiveness verification. If the switch statement covers all possible shape.kind values, then shape will never reach the default case. Therefore, the assignment to _exhaustive check will be impossible, and TypeScript will throw a compile time error. 4. Adding a new shape. If you add a new shape, like triangle in the example, and forget to update the getArea function, the default case will be reached because shape can now be a triangle. TypeScript will correctly flag this as an error, preventing you from shipping incomplete code. Benefits. Compile time errors. Catches missing cases during development, not at runtime. Maintenance. Makes it easier to refactor union types because TypeScript warns you if you forget to handle new cases. Alternative with return types. You can also use return type annotations to achieve similar exhaustiveness checking. If you specify a specific return type, and the switch statement doesn't cover all cases, the compiler will complain that not all code paths return a value. This is often cleaner than the never approach. 4. Common pitfalls, when unions break. Despite their power, unions can lead to unexpected behavior if not handled carefully. Here are some common scenarios where unions can feel broken and how to address them. Overlapping types. When union types have overlapping properties, TypeScript might not be able to narrow the type as expected. This is especially true with complex object structures. Solution. Discriminated unions are the best solution. Add a type or kind property that's mutually exclusive across the types. If that's not possible, use in checks or type guards, described below, to narrow the type. Type widening. TypeScript can sometimes widen the type of a variable, especially when dealing with literals. This can make it harder to reason about unions. Solution. Use as const assertions, or explicit type annotations to prevent type widening and maintain the literal types. Type guards. Custom type guard functions allow you to define more complex conditions for narrowing union types. They return a boolean and use the is keyword to assert the type. Important. Be very careful when creating type guards. They rely on runtime checks, so ensure they are reliable and won't produce false positives. The type of animal as bird, .fly == function example is common but potentially brittle. Consider using more robust checks based on multiple properties or data structures. Complex object structures and intersection types. When unioning complex object types, especially when combined with intersection types, TypeScript's type inference can become difficult to predict. The order in which you define the types can sometimes matter. Solution. Use discriminated unions whenever possible. Simplify complex type definitions. Consider refactoring your data structures to make the type relationships clearer. Explicit type annotations can also help guide the compiler. Undefined and null in unions. Undefined and null are implicitly included in union types unless you explicitly disable strict null checks in your xconfig.json. Solution. Enable strict null checks in your xconfig.json. Use optional chaining or explicit null and undefined checks. Generic type parameters and unions. Unions can become complex when used with generic type parameters. The compiler might not be able to infer the exact type you expect. Solution. Use conditional types more carefully and consider overloads for better type inference. 5. Advanced techniques for working with unions. Utility types. TypeScript provides utility types like extract, exclude, and pick that can be used to manipulate union types. Extract T, U extracts from T those types that are assignable to you. Exclude T, U excludes from T those types that are assignable to you. Pick T, K extends key of T. Constructs a type by picking the set of properties K from T. While not directly manipulating the union itself, it's useful for creating different types that use the members of a union. Map types with unions. You can use map types to transform each member of a union. Conditional types with unions. Conditional types can be used to perform different type operations based on which member of the union is currently being processed. This is very powerful but can also be complex. 6. Best practices for working with TypeScript unions. Use discriminated unions. This is the most important guideline for creating robust and maintainable union types. Enable strict null checks. Prevent unexpected null and undefined errors. Use exhaustive checks. Ensure that you handle all possible cases in your union. Keep types simple. Avoid overly complex union types, especially when combined with intersection types and generics. Refactor if necessary. Write clear type guards. If you need custom type guards, make sure they are reliable and well tested. Leverage utility types. Use utility types like extract, exclude, and pick to simplify your type definitions. Comment your code. Explain the purpose of your union types and how they are used. This is especially important for complex scenarios. Test thoroughly. Write unit tests to ensure that your code handles all possible cases of your union types correctly. Conclusion: TypeScript unions are a valuable tool for creating flexible and type-safe code. By understanding their nuances, avoiding common pitfalls, and employing advanced techniques like discriminated unions and exhaustive checks, you can leverage the full power of unions and write more robust and maintainable TypeScript applications. Don't just use unions, master them to take your TypeScript skills to the next level.